Hello Professor, this is my demonstration for assignment 4, Logistic Regression. First I loaded the data from the CSV file into the variable Titanic James, and then I printed the shape and the records and the information about this data. So by printing the shape, I can see that there's 891 rows and 12 columns. And by using isnum and info, I identified columns with missing values that are irrelevant, columns like name, ticket, passenger, and cabin, which I removed the dataset for analysis simplicity later on. In terms of data visualization, I generated visualization to explore within the dataset. This bar shows the number of survivors by passenger class, highlighting higher survival rates in first class. In the second bar chart, survival rates by gender shows that females had a higher survival rates than male passengers. And using the scatter matrix, I visualize the relationship among features like P-class and fare and sibling, which reveals potential correlation. For example, the higher fare passengers were likely to survive. In terms of, and then I just generated another scatter matrix using a different library, this time with the nicer colors, but showing the same set of data. I then prepared a dataset for transformation using getDummies. Before I did that, before I dropped the unnecessary columns, specifically the name, I captured their titles because I found that in having their titles as part of the model for analysis increase the accuracy of the model. Originally, without it, I was only getting 0.75 or 75%, but with the title column in it, I'm getting around 80%. Oh, and I forgot to. Did I forget it? Oh no, this is just it. So yeah. And then the name, I used the title name to average the age mean based on their title. That allows a proper distribution of what the average mean of the age for different titles instead of having just an average mean across all passenger for their ages, and that allows the model to have a better accuracy. Next, I wrote the normalization instructions with the formula here as indicated, and ran that. And here's a quick look of the normalized data. Now I separated the features into X James and Y James using train test split from sklearn. I split the data 70/30 with a random state to my student ID, last two digits for reproducibility. I then trained James underscore model on the training data. After feeding the model, I use cross-val score with tenfold cross-validation, testing different train test splits from 10% to 50%. The best results show a high mean accuracy and a reliable validation, so I chose a 30% split for final testing. Okay, so here comes the fun part. With the 70/30 split, I predicted the survivabilities using predict probe A, setting threshold of 0.5 and 0.75, and I recorded the prediction results. And here's the confusion matrix and classification report for 0.5 threshold, showing an accuracy of 80.6%, and for 75.75 threshold, accuracy actually drops slightly to 76.1%, but overall still higher than what it would normally look like without that title and factoring the title to the age mean. And that concludes my presentation. Thank you, Professor.